today today part in this part we will see how to do multiply any vector, any two vectors you can say. So in this part our focus will be on vector multiplication. When it comes to vector multiplication, then here we see that it is a being separated. It is divided into two parts when it comes to vector multiplication. Same here we will do. So one will be a scalar product or dot product. One part will be one will be a scalar product, or you can call it as a dot product. Another will be nothing but vector product, vector product, or you can call it a cross product, cross product. It's not a rocket science. It's very easy if you understand it carefully. We are going to multiply two vectors, okay, two vectors, three vectors. But in this part, our focus will be on two vectors. So how to multiply any two vectors. So remember, when you will take two vectors, so sometimes you will realize, sometimes you will observe that is after multiplying two vectors, I am getting what third vector is coming, which is third unit is coming, third thing is coming, which is not vector, it is a scalar. Okay, if this is happening, so this type of discussion is kept in this section, in the field of scalar product. After multiplying two vectors and third is coming scalar. Okay, in that case, that part is known as a scalar product, or you can say dot product. Whereas if whereas on the other side, you are bringing two vectors, and after multiplying those two vectors, you are getting another third vector. In this case, we were getting a scalar as a result, and in this case, we are getting vector as a result. So this is a difference. Okay, in both cases, we will be multiplying, but there will be some rules to multiply two vectors in this case. Okay, and that not rules of this discussion will be different from this discussion. From this dot, you are crystal clear. Dot means this. Meaning of this is what? Meaning of this is multiply. And here cross means this cross. Cross, multiply. Okay. Overall, we are multiplying two vectors. But here, you took two vectors, and after multiplying those vectors, you are getting a scalar. In that case, you keep that part as a scalar product. Okay, this happens. On the other side, you are taking two vectors, but after two vectors and you multiplied, you got a result which is a vector again. So this part you are keeping in the field of vector product. That is why we divided this vector multiplication into two parts. First part is a scalar product, and second part is a vector product. So a scalar product and a dot product, both are not different. Meaning of both is the same. In same here, vector product or cross product, the meaning of both is the same. Let's break down it in details. Let's understand this scalar product with example. With example. In other word, you can say when you are multiplying vector dot vector and you are getting a scalar. Okay, same here you do, but in this case, what will happen? You take one vector, again another vector. In that case, you are getting again third vector. This happens. In both cases, we are taking vector. Okay, but result in this case, result is a scalar. In this case, the result is a vector. Clear? Now, this f dot s is equal to w. We have this example. Now, work is defined as a force multiple displacement. If somebody is applying force on a box and that box displayed that box did displacement, in that case we say yes, work happened. We say that yes, work happened if force is being applied on a box and that box did move. In that case we say that yes, there is a work. Yeah. So same here we took work as an example to understand the dot product. First vector is a factor. First vector is force. This force is a vector. Uh, Displacement is also vector. Here dot means we are using dot product, and or you can just product. So this is the first vector, this is another vector. We are multiplying both vectors. After multiplying, we are getting work. You know that force multiple displacement is equal to work. Okay. Force multiple displacement is equal to work. Okay. Clear? This is clear. Now my question is, this is vector, but this is not vector. It's a scalar. It's a scalar. A lot of times it will happen. You are taking two vectors, but the result is coming a scalar. This will happen a lot of time. Okay. Now let's apply some logics in this. Some logic. F is equal to torque. Radius multiple force is equal to torque. This is torque. This is an example for cross product. In this case, we took two vectors and we are multiplying. R vector multiple radius vector multiple force vector. We are getting torque. It means this is a object. We are applying a force in this side and we are applying a force in this direction. And of course this will move. So this is nothing but radius. We consider it as a radius. When we are applying force, it is moving. In details we will explore it later in separate lecture. Right now just understand we are applying force and in this direction and this force in this direction. In that case, of course, it is moving. So this is known as a torque. Radius multiple force is equal to this torque. Torque is a vector. Radius is this is also vector, and if force is also vector. Here you are observing that by multiplying this by this we are getting again vector. This is known as vector product. Okay. I hope till here this is clear. Now next thing. Have a look on this. Here we are exploring first of all dot product, a little bit information about a dot product we have seen, as well as about cross product we have seen. So we are going to break down this dot product, then we will jump on cross product. Okay. Here we took this example of W is equal to Fs. Now we are going to apply logic so that we can get more clarity. Look over here. This is a one thing which will give you logic. This is one thing which will give you a logic. What is happening over here? We are multiplying this by this. Okay. F vector into S vector into S vector. See over here. Magnitude of this would be what? F. And magnitude of this displacement would be what? This S would be what? S. Okay. Magnitude of this F would be this F. You know that this vector, mode of this vector will be equal to F. You are crystal clear about. You are familiar with this. Same here we did. Magnitude of this F vector came out as a F, and magnitude of this S vector came out as a S. But what about this cos theta? Okay, cos theta. Cos as it here we are saying there is a box. Okay, box. There is a box. Force is being applied in this direction. In this direction. This is box. This is a box. Force is being applied in this direction. Now tell me, in which direction this box will move? In which direction? You would say same. In same direction it will move. So what is happening over here? Theta is coming. This rotation in same. If force is being applied in this direction, so of course same in this direction this box will move. So here our theta is coming 0. We will apply over here 0. So finally F is and cos theta 0 is what? 1. Yeah, 1. Cos theta cos 0 degree is equal to 1. So finally we got F is. So this is equal to W. W is equal to Fs. Clear? Why did we bring this AB not this A vector, because here we are finding magnitude, not a direction. We are finding magnitude, not a direction. That's all. So magnitude of this A vector, of course, it will become A. Same with this B. But okay, till here it's okay. But what about the cos theta? Why did we bring this cos theta, this trigonometry? We took this because we are getting a angle. We are getting angle. Box is on ground, and force can be applied in this direction. So here we are getting this theta. So theta is a, I would say this is a compulsory. This would be important. If you ignore this theta, so of course you will get error. That's why. So here a angle is being formed. That's why we took this theta. And we are in this direction. So this is for cos. Yeah, remember when you are in dot product, then you will take this cos theta. When you are in cross product, then you will take sin theta. Here you can say we are. This is a dot. Suppose we are in dot product. In the discussion of a cross product, we will see what here will be this cross. But this will be replaced by sin theta, because we will be in the discussion of vector product. Okay, I hope you understood something from this part. Okay, now what if this is a box? Okay, this is box, and person is applying force on this box, but this box is coming in this direction. Means this is a displacement, but force is in this direction, and displacement is happening in opposite direction. This is happening. This is happening in another case. In that case, you can say our theta is a 180 degree. This is our theta. This is a 180 degree. Just put 180 degree in the place of a theta. You will get result. So this F into S is equal to this F is a magnitude, S is a magnitude, S is a magnitude, and cos 180 degree. This is nothing but minus 1. This is a minus 1. So minus F into S. Minus F into S. This is our answer. So W is equal to, it is telling you that our box direction is opposite. It is telling that our direction is opposite. Now next thing. Next thing. Next thing is that we are taking two components, or you can say two vectors. Okay. This I, first of all, you know when you do multiple, this are two vectors, A vector dot B vector. Okay. Then what happens? We want magnitude. In that case, we will convert it into magnitude by using mode. Same with this vector. Okay. Then we have cos theta. Clear? Here we are saying that this is equal to this. Now we are taking two components. These are two components. We are taking this are two components. Or you can say two vectors. Now tell me, magnitude of this is what? We have two components. So magnitude of this is 1. And magnitude of this is 1. Okay? So this will become 1. Next we have cos. How much angle do we have? How much angle do we have? How much angle do we have? This is what we have to find. How much angle are we getting? So here from this components you will be able to find your angle. Here our this I cap is this and this is y cap and this is another j cap. So this we have two I cap. So of course 1 and then again 1. And it is giving you 0 degree angle. 0 degree angle. Okay. So angle is 0 degree. So finally cos 0 degree is 1. Cos 90 is the 1. Sin 90 is 1. So finally this is nothing but 1. This is nothing but 1. I cap dot I cap is equal to 1. Okay, same components. I would say same components. Multiplication of a same components in dot product will be 1. Will be 1. Okay. Next we have z cap. Z cap into z cap. Now this one magnitude of this vector is 1. Okay, this one multiple 1 it will become 1, and again it is going in this direction, same in this direction. So right now here you can see this is nothing but 0. This is a 0. So again 1. Same it will happen with the k cap. With the k cap. Clear? In this you are understanding if you multiply two components and that those components are same. Okay, in that case we will get a result which will be 1. Which will be 1. Okay. Why will we get 1? This is your process. What if we take this I cap and then another j cap? In that case, what will happen? Is it possible to get result if we will take this and this, not the same but a different? Yes, it is possible. But result, I would say result would be different. Let's just say we are taking this I cap and then j cap. In that case, so finally we have two vectors. Let's consider these two components as a vectors. So this magnitude of this would be 1 and then magnitude of this would be 1, again 1. Okay, no problem. Now cos I would say here. Now tell me what is your angle? So this is one axis and another axis is this, and here this angle is probably 90 degree angle. So we are getting 90 degree, and cos 90 is nothing but cos 90 is 0. So this is becoming 1 multiple 0, which is 0. okay, which is 0. If we multiple two components which are not same, okay, in that case result would be 0 because angle is 90 degree, so cos 90 is 0. Same it will happen with another component j k cap, so you will get 0 k I cap 0. Okay, I hope you have understood. All this will happen when you are in the discussion of dot product. Just have a look. Now let's take some examples. We have 89 cap into not 82, and then again I cap is equal to. We have this equation you can. So 8 I cap, a object moved 8 I in this direction, and again in this direction 2 more in this direction. So magnitude of this vector is 8 and magnitude of this vector is 2. It is becoming 16. But my question is, what about the cos theta, cos theta? So cos here this is IR. So of course this cos 0 here cos 0 is coming. So value will be 1. What if we take 8I into 2j? In that case, what will happen? 8, okay, and then 2. But okay, 8 to the 16, clear. Now cos and 90. So of course this is becoming 0. That is why you will get 0 if you take like that numbers with different components. Then at the end you will get a 0 result. At the end you will get a 0 result if you take different components in that case. Next question. This is our next question. Try to understand it. We have two vectors whose values are given by the question. So this is one vector and this is another vector. Value of this vector is this and value of this vector is this much. Clear? I hope you understood question. No. Question is saying you have to apply dot product. Dot product. So multiply this by using dot product. This is your question. So this A vector dot B vector will be what? It will be what? You are already crystal clear that if you multiply this I cap dot j cap, you will get 0 result. Of course, you will get 0 result. Same if you do this j cap then I cap again 0, k cap then I cap again 0. But what if you take this I cap and same I cap? In that case, you will get 1, 1. And remember, we are going to multiply, not add. Okay. So 7 to the 14 and I cap into I cap will be 1. Plus minus minus. Okay. 2 3 is a 6. Okay. 2 3 is a 6. So you are getting 14. 14 is the magnitude. Right now, we don't have direction because we are using dot product. Clear? So this is your answer. When you apply dot product, you got 14. If you apply cross product, you will not get 14. Answer will be different. We will see after understanding concept of a vector product, we will take equation and then you will observe what is the different from this. This was a simple equation just for understand dot product. Find angle between two vectors. This is the next question, which is a little bit different from the previous, as we did previous question. But here in this question, it is asking what is the angle between given two vectors. Between given two vectors. Can you tell me? Could you tell me what should be angle between these two vectors? Value of this vector is a 3i cap, and value of this b vector is a given, which is a 4j cap. Just you have to apply that important thing, which is nothing but this magnitude of this vector would be a, magnitude of this b vector would be b, and then we are taking quotient because we are in dot product. Clear? We will apply this over here so that we can get angle. So of course from this we will get angle. So B, okay. So we have this and this. Hmm. 4 3 is 12. 4 3 is 12. Now look at over here. So 3I this then 4 is equal to what? AB AB cos theta. Okay, AB cos theta. So now here you know we have different components. Of course, result would be 0. Then AB cos theta. Clear? AB cos theta. We just put value of vector A over here and value of vector B over here, and then after multiplying this we got 0. If we bring this AB in this side, this again will become 0, and finally we have left thing which is a cos theta. So now tell me how much angle should we put over here, then this value will give us 0 degree. So how much angle? I think 0, not 0, 90. So finally angle is what? Between these two vectors, angle is 90 degree. Clear? Between these two vectors. That is how you will find by using this. Now next to vector product. Till here this is enough about dot product. Vector product. Always remember we are taking two vectors, right? This one and then this another. It is also known as cross product. Cross product. This A vector into B vector. So always if you right now you are in vector product. So remember we will have sin theta. If you are in dot product, you will have cos theta. So magnitude of this would be A, and magnitude of this vector would be B, and then we have sin theta. But if you do like that, this is incomplete. This is half information. If you do like that, at the end you will get magnitude only. But we know that if we multiply these two vectors, we should get again vector. But we are doing like that. At the end, of course, we will get magnitude. Of course, this is wrong. To get direction, to get vector, we will have to use one more thing, which is n cap. N cap will give you direction. We used this so that we can get direction at the end. Okay. From this you will find a lot of things. For example, this if you take this I cap, not I cap multiple j cap, or you can say again I cap. Okay, we took two vectors, which is I cap again cross I cap. Now angle you have You have seen that if we take same components, angle would be 0. If you take different angles, different components, angle would be 90 degree. Okay, in the case of two angles. So I cap multiple again I cap. Okay. Now magnitude of this would be 1. Again magnitude of this would be 1. Sine, so angle is 0. Angle is 0. So sine 0 is 0. Sine 0 is 0. Magnitude is 0. There is a no direction. Magnitude is a 0. Okay. So if a magnitude is 0, so we cannot be say that we don't have nothing. We have nothing because magnitude is 0. Magnitude is a 0. That's it. Same z cap into z cap. Again you will get same thing 0. It will happen with the k cap. Again 0. Again 0. Okay. But what if we take different components, two different components, for example I cap into j cap. In that case, magnitude of I 1, magnitude of j 1, sine 90 and n cap 1. Okay, sine 90 1, again 1, j cap. Now tell me, one thing I would like to introduce is that when you are in dot product, so remember this can be written as, it can be this orders can be changed. B can be written first and then A. This is valid in dot product. You can change orders. But when it comes to vector product, you cannot change orders. You cannot change components. If you change, then of course direction will be changed. Direction will be changed. That's why. In this case, nothing is changing. We didn't change nothing. Our result would not be different. Our result in the both cases will be same. This is valid in dot product. But what if you want to do this in vector product? In that case, this will be invalid because direction will be changed. Clear? So this we will have to write in same orders. In same orders. Remember, brother. This is valid in vector product. This was very important point. Clear? For a few seconds, have a look. Now, we were over here 1 and we left this n cap. Same, if you take this j into k cap, you will get again n cap. K cap into I cap, you will get again n cap. I said something in this. What? If you change your orders, direction will be changed. So that's why direction is a compulsory. Anti-clockwise and clockwise. There are two directions of angles. Okay, there are two direction of angles. One is anti-clockwise direction and another is a clockwise direction. These are two directions of unit circle. Unit circle. Now, so this n cap is nothing but third cap. This is a third axis. In this we have I cap, j cap. So next would be k cap. So this is nothing but k cap. Okay. But question is, if our direction is in anti-clockwise, if our direction is in anti-clockwise, in that case this k cap will be positive. But if you are moving, if you are rotating in clockwise, so yeah, symbol would be, I would say, direction would be negative. So that's what here the sign will be important to apply. If you ignore this sign, of course you will have error. Okay. So we are moving how? This is one and this is another. This I cap and this is j cap and this is k cap. Okay. There are three components. So first I cap, this I cap, then j cap, and the result is coming k cap. So we are rotating like that, which is a clockwise anti-clockwise direction. In that case, this is considered as a positive. So this is positive. J cap. This is j cap, then k cap. Of course, next axis is coming, which is I cap. So this is nothing but I cap. Okay, I cap, and it is rotating anti-clockwise. K cap, I cap. This k cap, I cap. Next is j cap. Next is j cap. Again, this is a anti-clockwise. That's why all these axes are positive. But what if you take this uh, j cap and then I cap? Okay, k cap, then j cap, I cap, then k cap. In this case, do you think that this same thing will come? Yes, this will come, but direction would be something. Let's say j cap, this is j cap, and then I cap. Then of course next is coming k cap. It is rotating in this direction, which is a clockwise. In that case, this clockwise will be considered as a negative. Okay, so this is a negative. K cap, j cap. So k cap, j cap, k cap, j cap. Then next I cap. Again clockwise. So clockwise is negative. I cap, then k cap, then j cap. Clockwise, so negative. Okay, brother. So I k. Here will be k cap. K j I. K j I. Next is I cap. I k. I k. Then next is j cap. This has happens. It is happening because angle is 90 degree, and it's all about the direction and angle. Okay, it's all about when you are in vector, then it will depend on direction and angle. But if you are in a scalar, you can ignore direction. Okay, your focus will not be on direction when you are in the discussion of dot product. Just I will for a few seconds so that I can write next thing. Next thing. Next we have question based on this concept. Based on this concept, a cap there are two vectors whose values are given. Whose values are given. Value of this vector is 2 I cap plus 3 j cap. Value of this b vector is 4 I cap minus 3 j cap. And you have to solve this by using vector product. Vector product. Now look at components. If you are going to multiply this by this 2I cap plus 3j cap and then 4I cap minus 3j cap. Okay. You can write like that 2I cap then 4I cap minus 3j cap. Clear? Then plus 3j cap 4I cap minus 3j cap. That is what you will do. Now let's multiply 2 4 8. I cap is what? 0 because sine 0 is a 0, so that's what this will become 0. Minus will be as it 2 3 is a 6, but here we have I cap and j cap. I cap then j cap. What is happening? So next is coming, next axis is coming, which is a k cap. So I j k, so of course positive. So k cap, then we have plus 3 4s are 16. J I, first j, then I, then k. It is a negative, so this will become negative. 4 3s are 12. So next is a k cap. Now plus minus minus, of course this will become 0. So you are getting nothing but minus 18 k cap. Is this correct? Yes, this is correct. Observe over here. Here we wrote this minus. We applied this minus because of next component is coming, which is rotating in clockwise. So rather than applying addition, we replaced this by negative because it was moving in clockwise direction. That's all. Did you understand something? Did you understand something? This is your answer. Have a look for a few seconds. Here I will write some definitions of some important words. As we start our vector chapter, then we begin from quantity, physical quantity. Am I right? There are two types of a quantity. First is physical, and another is an unphysical quantity. So we will take, of course, physical quantities, because unphysical quantities are not taught in physics in this chapter especially. So here I want to say uh, any quantities you are taking, okay, any quantities. I am just saying, can you measure those quantities that you took? Can you measure? If yes, then those quantities are nothing but those quantities are vector. Those quantities are physical quantity. Physical quantity. Because you are able to measure. That's why. If you are not able to measure those quantities, those quantities are unphysical quantities. It can be hate, it can be love, it can be fighting, it can be crime. So all these are quantities, but we are not able to measure. We are not able to measure all this physical quantity, unphysical quantities. On the other side, there are a lot of physical quantities like speed, velocity, acceleration. Apart from this, there are more. All these quantities anybody can measure. So that's why these quantities are kept in physical quantities. Okay, in physical quantities. Okay. Now, as color quantities, we have ignored unphysical quantities. We have ignored unphysical quantities and we have accepted physical quantities. Clear? Physical quantities. So if you are understanding scalar quantities or vector quantities, it means you have taken physical quantities, not unphysical quantities. Clear? Scalar quantities, these are physical quantities, but this physical quantities do not provide a direction. Okay, these physical quantities do not provide direction. It has they have magnitude. Okay, so magnitude is nothing but value plus unit, number plus unit. This is a definition of a scalar quantities. Those quantities which are not providing direction, but they have magnitude. For example, distance. Distance is always a scalar. Distance is always a scalar. It can be measured, but this does not give us direction. Okay, next we have vector quantities. Next we have vector quantities. These are also physical quantities. I'm not saying that vector quantities are unphysical quantity and scalar quantities are physical quantity. No, all of these are physical quantities. Difference is this quantities do not provide a direction, but this quantities provide direction. Is it compulsory to have a direction? My answer would be yes. It would be compulsory to have a direction according to requirement. So these are also quantities. This physical quantities provide direction, provide the direction. Okay, they have magnitude, as well. For example, for instance, velocity, displacement, it is, for instance, velocity, displacement, all these are physical quantities and they have direction plus value, plus values. How to represent how to represent vector, vector. So to represent vector we use this symbol, this is how we communicate with these vectors. Rather than writing this vector word again and again, you can use this symbol, and we use this symbol like that, a vector. Here we are saying a is a magnitude, here we are saying that a is a magnitude, but this direction, this arrow is for direction. We are able to interact with this given thing. We are understanding that yes, there is a magnitude, this arrow is a direction. Okay, now let's say more about this arrow. This line segment, I'm not talking about this arrow, this line segment is a magnitude, this is a magnitude. Okay, but this arrow is a direction, this arrow is a direction, this is a magnitude and this arrow is a direction. Now one more thing, this ending part, this ending side without arrow, without arrow, this ending side, this is considered as a tail, clear? And this side which is with arrow, this is considered as a head, tail head. It will help to you in upcoming concepts. So this side which is without arrow is considered as a tail, and this side which is with arrow will be considered as a head. Okay, this line segment is magnitude and this arrow is a direction. This was about this arrow, that is how we represent any vector. For example, we have displacement. We know that displacement quantity have what? Arrow direction. So that's why we can represent this arrow over here. Now this is a complete information about vector. It is saying that yes, there is this quantity has direction when we apply this arrow. Clear, brother? Now, apart from this, I have one more thing. Not about this, but there would be connection of this magnitude of any vector. How to convert any vector into magnitude? That is what we are observing over here. We are understanding over here. How to convert any vector into magnitude. This will also help in upcoming questions. This is a given vector. You want to convert this into magnitude. Just apply this mode, this parallel. It is telling you that this is equal to A. We use this mode so that we can remove direction, not magnitude. We just applied this mode because we want only magnitude. So this is equal to magnitude. You cannot say that this is equal to vector. No, it is a rho. Clear? In your question, you will see that question is saying find magnitude of this given vector. And there is a formula also. Magnitude of any vector. Under root of a square plus b square, like that. Then a 2ab cos theta. This that. Okay. Now one more thing, which is about unit. Unit vector. This a cap. A cap, it is a type of vector which is known as a unit vector. Unit means magnitude is 1 and direction is specified. So this unit vector is used for a specified direction. Magnitude will be always 1. Okay. Don't think about magnitude because magnitude is a fixed for unit vector. So here, observe over here, say over here, this is equal to magnitude of this, as we said that magnitude is 1, and now you will observe there is a logic. Magnitude of this vector upon magnitude this is. You know that at the end this will become a and upon it. This will cut to each other by 1. So what are you getting? A cap is equal to 1. Magnitude is 1. Magnitude came as a 1. And this is the definition of a unit vector. So main focus was our on this. A cap is equal to magnitude of a vector upon a. That's it. Okay. Then after this we will say types of vector. Types of vector. Let's explore types of vectors. First is collinear vector. Collinear vector. Collinear vector. A vector, there are more vector. Okay. From this word, you should be clear. Linear. More vectors are in same direction along a line. This is one vector, but another vector should not be parallel, not parallel. Okay, I would say angle should be 0. Angle should be 0. Okay, collinear. So main is what? Linear. So all these vectors, this vector should be in single line, along line, like that. Not upward, not downward. Clear? So if there are 2 or more vectors and all those vectors are in straight direction along a line, so this is a definition of a collinear vector. Clear? That's it. Coplanar vectors. Coplanar vectors. 2 or more vectors which are on a single plane. For example, this is a ball. This is a one plane. And all the vectors are on a single plane, on this plane. This is a definition of coplane. Vectors that are on a plane, coplane vectors. Okay, next we have negative. Negative of a vector. Negative of a vector. This is a vector. It is a positive. Okay. Magnitude should be same. Okay. It says that magnitude should be same. Magnitude should be same. So you will have to take one more. One more. This is the same. Whose magnitude is the same. So magnitude of this and this both are same. But main game is direction will be opposite because of negative. Here word is a negative. So negative means a direction will be changed. So if this is this one vector is in this direction, so just opposite of this direction will be like that. This is a negative of this vector. This is a negative vector of this positive vector. This was about the negative of a vector. I hope this point is clear. Okay, next let's see. So remember, in this case magnitude will be same but direction will be opposite. Now next, equal vector, which is very easy to understand it. Equal vector. Same again, you take two vectors. Okay, two vectors. In this case, it states that all things will be same. Nothing will be opposite. Magnitude of this vector and this vector should be same. If this is a 5 centimeter, this is 5 centimeter, both should be 5 centimeter. But direction also should be same, not opposite. If this vector is going in this direction, so this vector should go also in this direction, same direction. So direction and magnitude both should be same. Okay. Now next, null vector. Null vector. It is also called as a zero vector, which means whose magnitude is zero. From this word we are getting clarity. From word we are getting clarity. Null means zero. Magnitude is zero. Okay, there is no direction. Sometimes you will realize to have this null vector in some questions. Next we have unit vector, which I have explained. Unit vector, it has only one magnitude and it is used especially for direction. This unit vector is used especially for direction, where magnitude is always zero. And I have explained more about this unit vector in the previous part, remember. Now initial vector, co-initial vector. Co means compound, two or more. Okay, co means compound, two or more. Initial means starting. So here we will take starting point. This is the starting point, and from this point, whatever would be number of vectors, it doesn't matter. But that tail of that vector should be start from this point, like that. Okay, like that. Condition is all this vector, tail of all these vectors should start from this initial point. This is a main point to define co-initial vector. Okay, all these are vectors, but tail of all these vectors are starting from this main point. Clear? What? What else? What else? Once we completed this, we will jump on laws of addition vector. Laws of addition vector. There are three laws: triangle law, and parallelogram, and then polygon law. Polygon law. Once you understand this, then now let's see polygon law. Polygon law of addition vector. You have this vector 1, then again 1, like that, again 1, then again 1, like that. There are 4 vectors, and all these are arranged in this way. Question is saying apply polygon law and find resultant. In this case, remember always remember, if you are going to draw a vector which would be resultant vector, in that case, always remember you will have to connect tail of your resultant vector with this given vector. So this tail to tail, and then here it will be connected head to head. This is our resultant vector. This is our resultant vector. Are you understanding? A vector, B vector, C vector, D vector, all this were given by the equation, and we found this resultant vector. This is a correct way. If you start like that, and then again like that, so this will be incorrect way. This resultant will be incorrect, because this is a head and it's a tail. That's why both should be same. Indent should be same. Same it happens in triangle. Same it happens in triangle. We saw this diagrammatically. Okay. Now, next triangle. When you are in triangle, remember at the end you will have three vectors, including a resultant vector. Because triangle means three vectors, three sides, three line segments. Let's just say question is given. Question gives you a question. This is a vector and another is like that. Do you know how to shift any vector parallelly? I will tell you. We are talking about a triangle right now. This is one vector which name is a vector. Okay, this is another which is a b vector. What will be resultant vector in this case? Diagrammatically, I am saying diagrammatically. Okay, so I told you, if you are going to draw another vector which would be resultant, so remember, connect tail to tail and head to head with a vector. So this is the tail. So we are starting with, we connected tail to tail, and then it will automatically connect head to head. This is our right resultant vector. Okay, you can consider it as a R vector or C vector, whatever I am saying. This is the correct way and this is the correct way. And thus you can say we have 3. If you have more than 4 vector, then use polygon law. If you have four vectors, then use, I would say, two vectors. Four vectors, then use parallelogram. If you have three vectors, then use this triangle law. Okay, triangle. Now, how to shift any vector? Look, this is vector. This is another vector. It is very simple to shift any vector. But remember, there are some points that we will have to keep remember in our mind, which are, when you are shifting any vector, so don't change the direction of that vector. The direction of this vector should not be changed. Remember, should not be changed. You can parallelly shift this over here like that. Like that. It can go upward also, it can go downward also. But one thing you can observe is that we are not changing direction of this vector. This is valid. But as you change direction, it will be new vector. New vector. Okay. So this is also a vector, 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 and this is also a vector. Because we didn't change our direction. This will help you a lot of times. We can shift this over here like that. Like that. Like that we can shift. And another would be like, but this is in this I was talking about how to shift any vector. Question is given like that. Question is given like that. Question is saying use a triangle law and find the resultant vector. What to do? What to do right now? Without shifting vector, any of them, it will not give us a resultant. If you do it like that, you can see this is it and this is it, this is it, which is incorrect. Both sides should be shifted. In that case, what if you shift this over here parallelly, it will come over here. Now see here. Now see now. Are we getting resultant vector? Let's see. Yes, we got result. This head, this a tail, this a tail, this head, this a tail. In this case, we are getting a resultant vector. This happened when we shifted a vector. Then it became possible. Question was like that. Like that. But in this case, without shifting vector, this was impossible to bring a resultant vector. When we shifted this over here, then it became possible to bring this resultant vector.